Hi, this is Team 6, and I'm Xavier.
I'm Trevor.
I'm Tanner.
I'm Travis.
And this is our smart door lock.
Through 20 interviews with stakeholders, we established the user needs list. We learned users are most concerned about the lock's safety, durability, and ease of use. In the raw data we gathered and research conducted, we established our list of requirements to include a Wi-Fi capability with a range of 12 meters, a strength to withstand 1,335 newtons of force, an operating speed to lock and unlock in under 30 seconds, and a battery lifespan of no less than 1 year.
So I'm Xavier, and I'm going to speak a little bit about the specifications of our smart door. So to begin with, we have a servo that produces a torque of about 1.34 kilograms per centimeter, which is very efficient for our design. We also installed waterproof capabilities, so there's no worry with other weather options coming your way. So we delivered on our promise to make it Wi-Fi accessible, so that's extremely convenient, and that approves of our mission statement. Furthering that, we also have a sufficiently long battery life with a battery of 5,000 milliamp hours. So that's incredible for us on our budget. Although we did not meet a promise that we had made for ourselves to deliver on an NFC capable door lock. And that's just because of the quickly arising due dates that were before us. So we hope you enjoy it.
Okay, so I'm going to go into some of the detailed design components of our smart door lock here. The primary CAD software that we use, computer-aided design, was SolidWorks. That's where not only the door itself was designed, but some of the components inside as well. The other software that we used was actually Siemens NX10, and we used that for finite element analysis of the bolt itself, just to make sure that it could withstand the force requirements of a break-in. So let's jump into some of the details of that now.
Okay, so you can see here that we have the entire door modeled in SolidWorks with the exception of the frame on the outside. So all of these side pieces here were actually cut out of wood on the laser cutter, but drawn up in SolidWorks first, as well as our clear window right here, which is just to give the viewer a little bit of the inside of the mechanism of the lock. So I can actually do a little animation for you here of the lock. So you can see as the servo pulls back, that's pulled back, and these two are not connected in the model, but the bolt gets pulled back as well. All right, so you can see we're unlocked here, and then when we go to the locked position, the bolt is pushed forward, in which case that will be pushed forward just like that as well, giving the bolt a locked position. We also do have a manual override designed into the system. There's actually a spring inside the bolt here, so the bolt can be pulled back in the event that the servo here stopped working or was disconnected for whatever reason. We would actually have a separate key that would be linked to this that would actually give the bolt a separate mechanism to unlock just an emergency situation. But other than that, that is the CAD model that we have for the door. We also ran some finite element analysis on the door, which I can show here with these pictures. This was done in Siemens NX10. However, I don't have the software up currently. These are just some screenshots of it. But you can see here where the max stress of the bolt is going to be on the side here, as well as these sides here, and you can see the deflection in the bolt when we add our Newton force to the bolt as well.
For fabrication, our door was scaled down to make it a little bit easier to build. The wood was received through the startup labs, and it was cut on the laser cutter in the startup labs as well. The plywood base was just cut using a chop saw. The 3D printed parts on the inside for the actuator and the door lock itself were printed through the startup labs, and the ESP8266, which is the microcontroller for it, was bought through Amazon, as well as the battery, the cable, and the rest of the bought components.
So because we were using an Arduino, we of course had to write a code to connect to the Wi-Fi Stinson with password test. Once it was connected, it would then go forth and create an HTML document that had two buttons and a piece of text that would say whether the door was locked or unlocked. The Arduino itself would then read and update itself whether the servo was on or off, corresponding to different lock or unlock positions.
In conclusion, planning downstream production would be a plan for us. However, we would have to devise a plan, a market plan, which would allow us to advertise our door lock, our smart lock, and continue to be a competitor within the wireless lock industry. We hope you enjoy. Thank you for your interest in Team 6's smart door lock.